Okay, so it's question 2 from the June 2021 paper. So they said two quantities n and t are related as follows, and it says n is equal to the square root of t, and they want us to find the value of n when t is equal to 49. So what we'll do is say that n is equal to, this is substitution, basic substitution. So all you're doing is wherever you see t, you replace it with 49 from the formula. So it is n is equal to the square root of 49, and as Selena rightfully says, when you put that in your calculator, you will get 7. So n is equal to 7 when t is equal to 49. Part 2 now says make t the subject of the formula. So we have t, n is equal to the square root of t. So first thing that we're going to do is to square both sides of the equations. I'm taking it in steps. So, and when we're squaring both sides in order to get rid of the square root here. So what we'll do is n squared is equal to square root of t squared. And this is how we cancel the square root from the right hand side of the equation. So the square will be cancelled out with the square root, and therefore in making t the subject of the formula, we'll have n squared is equal to t, and this is our answer. So t is equal to n squared. So very good, Selena. So this is our final answer in making t the subject of the formula. Any questions from those two? And by the way, both those questions are 1 mark questions, so they expected that you guys should know. Go ahead, Ayana.
Excuse me, sir. So basically, you're writing the written form of the equation.
If I'm writing the
written form of the equation.
I didn't hear the last word.
Of the equation.
No, before of the equation. What form of it?
Written form.
The written?
The written form.
Or the written form. Because I guess you can say that, but basically because remember they gave us the equation here, which is n is equal to t squared. So all they're asking you to do is just to manipulate the formula in order to make another variable the subject. And I don't think there's any in the other question before, but it's like you'll see this a lot on other past paper questions where they'll give you formulas and it could contain more than one unknown variable. It's just that this one was a bit easier and it only had 2, but they can give you to make any unknown variable transposition, yes. So you're transposing. So you are just making any one of the variables in the formula. The subject, in this case, it only had 2s, and they asked us to now make t the subject of the formula. All right, so part B, it says Ali is X years. Jim is 5 years older than Ali. So let's take it in part. So if Ali is, okay, thank you, Selena, you're way ahead of us. But yes, that is what I was about to ask. So let's say you're looking at it. If I'm using numbers, if I'm 10 years old and Jim is 5 years older than me, the question was just basically asking, how would we get to Jim's age? You would say 10 plus 5, and that would have given us 15. But it's just that in this case, they are using letters unknown. So when they said Ali is X years and Jim is 5 years older than Ali, they asked us for Jim's age. So Jim's age is equal to X plus 5. So it is the X from Ali's age and Jim being 5 years older than Ali. So all we did was to add 5 to Ali's age and we would get Jim's age. And then it says Chris is twice as old as Ali. And as we've seen some of the answers already in the chat. So therefore, Chris's age is therefore 2 times Ali's age because he is, now remember Chris is, they're comparing Chris's age to Ali's age. So it would be 2 times Ali's age. So it would be 2 times X, and that would give us Chris's age. Because remember, all the age comparison is comparing to Ali. So Ali is X, Jim is 5 years older than Ali, and Chris is twice as old as Ali. So it would be 2 times X. It would have only been X plus 5 times 2 if they were comparing Chris's age to Jim's age, but they were actually comparing Chris's age to Ali's age just the same. And that is how you'll get 2 times X. And this is our 2 marks here. Very good, X times 2, and that is how we get the 2X. Part 2 now says, in 2 years' time, and I think this is where the challenge came, probably the first challenge on this paper. It says in 2 years' time, the product of Ali's age and Chris's age will be the same as the square of Jim's present age. And they want us to show that the equation x squared minus 4x minus 21 is equal to 0 represents the information. So we are proving this formula, quadratic formula right here. But if we're taking it in parts, it says June 2021. It says, it's a last year paper. It says in 2 years' time, the product of Ali's age. So in 2 years' time, using Ali's age, which is X, in 2 years' time, how old will Ali be? That is my first question to you. How old will Ali be in 2 years' time? No, all right, look at it, Selena. If Ali is 10 years old now, in 2 years' time, how would you have gotten it? Would you say 2 times 10? Because that would actually give us 20. So you're telling me that in 2 years, Ali would be 20. Very good. Instead, it would be X plus 2. So it would have been 10 plus 2 if the age was actually 10. So very good. It would actually be X plus 2. So this would have been Ali's age in 2 years' time. So it says in 2 years, the product of Ali's age, which means that we're going to multiply. So I'm doing bracket times bracket. So in 2 years, the product of Ali's age and Chris's age. In 2 years' time, what would be Chris's age? Very good. 2x plus 2, because currently Chris's age is 2x, so in 2 years' time it would be 2x plus 2. So we've worked out this first part. So in 2 years' time, the product, so you can see that they're multiplying, the product of Ali's age and Chris's age will be the same as the square of Jim's present age. So the square of Jim's present age, Jim is x plus 5. So what we're doing is x plus 5 multiplied by x plus 5, which is the same as x plus 5 square, but I'm just doing it like this because eventually we will need, so very good Takis, eventually we will need to expand our brackets. I'm just putting it out there like this from now. So this is basically what we are doing. So now if we're expanding our bracket, so what we'll be doing first is x times 2x, then x times 2, and then 2 times 2x and 2 times 2. And then for here, you're doing x times x and x times 5, and then 5 times x and 5 times 5. So that is how we are going to expand our brackets here. So what we'll have is x times 2x, that will give us 2x squared, and then x times 2, that will give us plus 2x. And then 2 times 2x, that will give us plus 4x. And then 2 times 2, that will give us 4, is equal to, we now have x times x, that will give us x squared. And then x times 5, that will give me 5x, plus now on to 5 times x, that will give me 5x, and 5 times 5, that will give me 25. All right, so Selena says x squared plus, all right, so very good. That will eventually work out to be the right-hand side of our equation when we simplify. So now going ahead, we have 2x squared plus, we have a 2x here and a 4x. These are like terms, so we can add them. So we'll get 6x here plus 4. So we get 6x from adding this 2x plus 4x to give us 6x, is equal to x squared, and we have 5x plus 5x, and that will give us 10x plus 25. Go ahead, Aaron.
So just like to know which year we're doing?
June 2021, last year paper.
Okay, sir, thank you.
No problem. So this would be, now we are going to carry over what is on the right to the left and equate it to 0, because remember that is what is happening here, because remember we're showing that this would be our final equation, which would be x squared minus 4x minus 21. So we're carrying over and we're going to add or subtract our like terms. So first we have 2x squared, and I'm putting this x squared here beside it, so it was adding here. So when it comes across, it will be subtracting. So I'll have 2x squared minus x squared. Then I have plus 6x, and I have a 10x here. When it comes across, it was adding here. So when it comes over, it will be subtracting. So I will have minus 10x. Then I have a plus 4 here, and the 25, it is adding here. So when it comes over, it will become a minus 25, and that is now equal to 0. Is everyone still with me? Did I lose anyone? So basically, what I did here, so before I could even insert an additional steps here to ensure that we understand. So if we should write back everything that is right here on the left, so we have 2x squared plus 6x plus 4, and we're carrying over everything on the right to the left. So the x squared, it was adding here, so when it comes over, it becomes a minus x squared. The 10, it was adding here, so when it comes across, it becomes a minus 10x. And the 25, it was adding here, so when it comes across, it becomes a minus 25 is equal to 0. And then basically what we did here is to group our like terms. So I take the 2x squared here and the minus x squared, put them together. I take the 6x here and the minus 10x, group them together, and the plus 4 here and the minus 25, group them together in order to get our final answer. Very good, Shanicia. Indeed, that is it. So when we can now do 2x squared minus x squared, that will leave us with x squared. So basically 1x squared. Now, plus 6x minus 10x, that will leave us with minus 4x. And we have a positive 4 minus 25, that will leave us with a minus 21, and that is equal to 0. And we have just proved proof from part 2. So this is basically, so they asked us to prove that from this information that this would be the equation that represented it, and we just proved that indeed this would have been the resulting quadratic formula. Any questions from that? So we started out by looking at the information that was given in 2 years' time. We're looking at the product of Ali's age. So this is Ali's age and Chris's age. We add 2 to both of their age, and it would have given us the square of Jim's present age. And all we did from there was algebraic working. So just work out, expanded our brackets, then added or subtracted our like terms, and we'd have gotten this final answer of x squared minus 4x minus 21. Someone is asking why is the Zoom setup so strict? It's not Zoom in an office sense. This is Zoom webinar. So what will happen is if you need to speak, then you will need to raise your hand. And once you raise your hand and you're given permission to speak, then once you're given the permission to speak, then your mic will remain open for the remainder of the class. Yeah, that's basically it. All right, so part 3 now asks us to calculate Ali's age. So remember, what was Ali's age? In the question above, what did they give us Ali's age as in the original part of the question? Very good, X. So Ali's age is X. So if Ali's age is X, from thinking back to mathematics, the only time or usually very good, you are solving for X, and you are using this to solve for X. And this quadratic formula that was given is what you will use to solve for X, which is Ali's age. So it will be x squared minus 4x minus 21 is equal to 0. So if you remember with quadratics, you are looking for 2 numbers. So our AC value, if this is how your teacher taught you, your AC value would have been minus 21. Very good, Takis. Minus 21. And our B term is equal to a negative 4. So you're looking for 2 numbers. When you multiply them, you get minus 21. And at the same time, when you add them, you're getting the B term, which in this case is minus 4. And those 2 numbers would be minus 7 and a positive 3. Very good. Now, alright, so if you realize that our B term is negative, so because our B term is negative, Renisa, we're applying the negative connotation, the negative operation to the larger number. Because remember, to get the B term, when you add them, so if we should add 7 plus negative 3, what you would get is a positive 4. And what we really want is a negative 7. So you'll allow the 7 to be negative and the 3 to be positive. And these are the numbers that we'll be using to replace our middle term. So what we'll have is x squared minus 7x plus 3x minus 21 is equal to 0. And now we can go ahead and factorize. Now if you do, that's what I'm saying, if you do -3, then you would not get the b term. Because remember, when we add both numbers, you need to get the b term, and the b term is a -4. The only way you can get -4 is if the 7, the negative sign. Okay. Very good. Okay. So yes, so when we factorize, what we'll get now is from these first two terms, okay, yes, you could also use a quadratic formula to solve. When we factorize here, x is common to both. So you say x into x squared, that will leave us with x into minus 7x, that will leave us with minus 7. And then from right here, we'll do plus 3 into 3x, that will leave us with x, and 3 into minus 21, that will leave us with minus 7, is equal to 0. Right here, they usually say factorize again, but what I tell students is that the common factors that you had used, you put them in one bracket. So you have x plus 3 in one bracket. In the other bracket is what is there, which would have been x minus 7 is equal to 0. And now we can solve for both values of x. So we'll have x plus 3 is equal to 0, or x minus 7 is equal to 0, which means that x is equal to -3, or x is equal to a positive 7. So as Taki says, Ali's age is 7. Why couldn't we use a -3? Why can't we say Ali? Because we got two values for Ali's age. We got a -3 and a positive 7. Why couldn't it be the other value? And this is just reasoning ability. Very good. That's just simple the truth. Because our age cannot be negative. We've never heard of anyone being -3 or -25. So we had to choose the positive or the more realistic value. So therefore, Ali's age is 7. So Ali is 7 years old. Any question from this one? Because this is now the end of part 2. Any question?